Assalamu alaikum wa rahmatullahi wa barakatuhu. So we are continuing with our topic induction motor. So in the previous video we have seen the basic principle of the induction motor, how the torque is basically produced in it, and why it can not only run at the synchronous speed, but there is a relative motion between the synchronous speed and the rotor mechanical speed itself. So the relative motion between the synchronous speed and the rotor speed is actually known as the slip, or we call it as the rotor slip. So the voltage induced the rotor power of induction motor depends on the speed of the rotor relative to magnetic fields. Since the behavior of an induction motor depends on rotor's voltage and current, it is often more logical to talk about this relative speed. So two terms are commonly used to define the relative motion of the rotor and magnetic fields. One is known as the slip speed. Slip speed is the speed between the difference between the speed of the synchronous speed and the mechanical speed of the rotor. So we call this as the slip speed. And we define the term slip if on a per unit or a percentage basis, if we just divide the slip speed by synchronous speed and make it in the percentages, so that would be n synchronous minus nm by n synchronous. This is in rpm, so we can also use the same slip formula for the radians per second if we are measuring the speed in radians per second. So this is very important phenomena in the induction motor, the slip. It is basically not present in the synchronous motor that we have seen, because in synchronous motor the rotor mechanical speed itself is at the synchronous speed, while in this induction motor we can see that because the rotor does not have its own magnetic field, so it always lags behind the synchronous speed. So it will try to catch up to reach the speed of these magnetic fields, but it can never reach at that speed. So that's why we have this slip phenomena, which is only present in the induction motor. So slip can have different values. So if the rotor turns at synchronous speed, obviously slip will be 0, because n ml will be asynchronous. So, and if the rotor is stationary, means if at the standstill or when we are just starting the motor, at that point the rotor slip will be 1. So Nm will be, actually we can write it in another way, 1 minus S into synchronous S synchronous, or sorry, this is N synchronous, where omega m is equal to 1 minus S into omega synchronous. So this is just simply derived from the what we have seen as equal to N synchronous minus Nm by N synchronous. So we just cross multiply here S into N synchronous, which is equal to N synchronous minus Nm. Now if we take Nm here and this term here, so N synchronous minus S into N synchronous. So here we can take out this N synchronous, so it will be 1 minus S into N synchronous. So this is just another way to find out this mechanical speed using the same relation, just little bit manipulated. So an induction motor works by inducing voltages and currents in the rotor of the machine, and for that reason it has sometimes been called the rotating transformer. Because why it is called the rotating transformer? Because if we just short circuit the secondary of the winding and give the secondary of the transformer a place to rotate, so it will start rotating, it will start moving. So like a transformer, the primary stator, here we call stator, so induces a voltage in the secondary. But unlike a transformer, the secondary frequency is not necessarily the same as the primary frequency. because in the transformer we have seen that it will transform only the voltages and currents, but the power remains the same, and also the frequency at the primary and the secondary will also be the same. So in the induction motor, it's a bit different, that if the rotor of the motor is locked so that it cannot move, then the rotor will have the same frequency as the stator, just like a transformer. So on the other hand, if the rotor turns at synchronous speed, the frequency on the rotor will be zero, because no voltage is induced, and what happens that the rotor feels with respect to the rotating magnetic fields as stationary. So if just like it's a relative motion, so if we just like riding on a bus, and with relative to the bus we are stationary, but with relative to the environment the bus is moving. So this is a relative motion. So obviously we know that this physics phenomena. So obviously this happening of zero frequency will be because of that the rotor feels that it is not moving, and we are there is no magnetic field lines are cut, so that the voltage would can be induced in the rotor. So here we can summarize here that at Nm is equal to 0, when the rotor is the motor is stationary, the rotor electrical frequency will be the same as the the stator electrical frequency, and the slip will be 1. So if Nm is equal to mechanical speed is synchronous speed, so rotor electrical frequency will be 0 Hz, and at that point slip will be 0. So we can just manipulate a few terms in terms of these rotor electrical frequencies. So for any speed in between, the rotor frequency is directly proportional to the difference between the speed of the magnetic field and the speed of the rotor Nm. Since the slip of the rotor is defined as n synchronous minus Nm by n synchronous, so we can define these Fre is equal to S times Fse. S is the slip. Okay, so that is means they have the relation between Fre and Fse based on the slip. So we know that if S is 1, so they are same. If S is 0, so Fre is 0. These two terminologies, these two limits we know. So here we can put the value of S here. So Fre will be P over 120 Fse, and then this will be the Fre P over 120 n synchronous minus Nm. So simply the slip speed can also be used to find out the rotor electrical frequency, given we know the number of poles of the induction motor. So this is all about the slip, and once again I will recap the slip, as the slip is a very important phenomena in the induction motor, and that does not happens in the synchronous motor. So the slip defines actually the relative motion that exists between the rotating magnetic field, synchronous speed, and the rotor mechanical speed itself. And because of this the we can have the rotor frequency which is different from the stator frequency, and the relationship that holds between them is based on this slip, and we know that slip is this n synchronous minus Nm by n synchronous. So I hope you have understood these basic principles. They are very important, and if you still have any questions, please feel free to ask. Assalamu alaikum wa rahmatullahi wa barakatuh.